So this would be what? Antiderivative. Sine over cosine, correct? If you don't know that, it's time to study. And we thought about a u substitution, right? Now, a lot of times, again, with these rational functions, if you can't split it up or you can't rewrite, cancel, stuff like that, make the denominator your u, and that leads to a natural log antiderivative. U equals cosine x, right? du. What's the derivative of cosine? All right, so then we have negative antiderivative 1 over u du, correct? What's the antiderivative of 1 over u? What is he missing? Absolute value. Yep. All right, negative natural log absolute value cosine x plus c. Interesting enough, we missed a lot of points on that plus c on our test, didn't we? Are we good? Pretty easy? Let's work on a couple of the other ones. Secant. All right, how can we rewrite secant? That would be what? It's kind of like rebounding. Rather have more than 1 than 0. All right. Let u equal cosine?
No.
Oh, we don't have a sign anywhere, though.
Let's just substitute it correctly. So it'll be ln u prime over u.
I don't see sign up here. That's not u prime over u.
Well, no, it's not right up like that. Oh, wait. Oh, we're going backwards.
You're never going to figure it out. Someone's going to tell you.
I'm not going to figure it out.
Leave it as secant, actually. And what we're going to do, folks, is you're going to multiply by secant x plus tangent x over secant x. Oops, I forgot my plus sign. Plus tangent x. So we're multiplying by 1, a different variation, different form of 1, secant plus tangent over secant plus tangent. And the reason why we're doing that, as you guys already kind of talked about, we need like the u prime over u situation, right? We don't have that right now, so we're going to force it to happen by multiplying by 1. We can do that. Now, if you look at this, guys, we're going to have secant squared x plus secant x tangent x over secant x plus tangent x dx. Now you might be thinking like I was back in the days when I was in college, when the teacher was going over something on the chalkboard, they're doing something like, how in the world they figure out how to do that? Well, you think about it for a long time. You try these different things and they figure this out. They figure out to force the u prime over u. Well, what derivatives have secant in it? What functions have secant? So they tried a number of different things. Now, we could sit there and investigate this forever, or I can just tell you to do this. Okay, it'll save a lot of time. Now, if you think about this, guys, if we let the bottom equal u equals secant x plus tangent x, what's du then? Well, the derivative of secant is secant tangent, right? The derivative of tangent is secant squared. They're out of order. That's okay. But we do have these two items. So it'd be secant x tangent x plus secant squared x dx, right? Now, obviously, addition is commutative. The order doesn't really matter when we're adding. We have u prime over u directly. So now we have new antiderivative 1 over u du. Things substitute very nicely now that we force the u prime over u situation. And then the antiderivative of 1 over u would be natural log absolute value. Let's just substitute what u is right away. Is that okay? What was u? Secant x plus tangent x? And then plus c. Okay, we'd actually do the same process with cosecant. Tangent, we do the same, or cotangent, we do the same process we did with tangent. All right, and then sine and cosine, we already know. So here's a good chart of all the antiderivatives of your trig functions that we need to know. Again, we know sine and cosine. We developed tangent on our own. We do the exact same thing with cotangent. We developed secant. We would do the exact same thing to develop cosecant. So remember, taking a picture of this does not help you learn it. Actually learning it helps you learn it. Study it. Go over it. All right, this is just going to be like square root 1 plus square root tangent squared, right? Thank you. Not just secant. What? And don't ever do this, guys. This does not work. You cannot break stuff up like that. It's the sum or difference inside a radical. You cannot do that. Oy, oy, oy. That didn't get you guys this time? Good. You're on to my tricks? Okay, square root secant squared. Which is actually kind of impressive that more of you guys know that 1 plus tangent squared is equal to secant squared now. It's good. All right, square root of a square. There we go. Okay, so what is the antiderivative of secant? Well, that would be natural log of absolute value, secant plus tangent x, evaluated from 0 pi over 4. Right? Okay, here's the fun stuff. Natural log, absolute value, secant, pi over 4, which you should be thinking that it's the reciprocal of another value. Tangent pi over 4 is everybody's favorite. Natural log, secant of 0 plus tangent 0. Okay, let's see here. Secant is reciprocal of cosine, right? Cosine pi over 4, well, that's right there, right? Cosine is the x value, and this would be what? Root 2 over 2? Reciprocal of that. Root 2 over 2. We should have done this on Tuesday. So that'd be root 2. So it would be a natural log of root 2. What's tangent pi over 4? Minus natural log. Okay. Cosine 0 is what? So the reciprocal of 1 is 1. So natural log 1 plus tangent of 0. Tangent sine over cosine. What's sine of 0? 0. So that means tangent of 0 is 0 also, right? So natural log, absolute value, 2 plus 1 minus natural log of 1. Let's keep going with that. What's natural log of 1? That's 0. Do we need the absolute values here? Not necessarily, right? Natural log. They could list as parentheses. We got to keep that in mind again. If you don't need the absolute value, why write them? So that'd be the exact value. I'd prefer exact values, but we know how to type that stuff in our calculator. Is that like 0.881 or something like that? Check me, see if I'm right. Careful on the parentheses on that. All All right, a lot of good stuff. Think of how much you guys know now to be able to do this type of problem. This is a pretty involved problem. We got a rewriting skill. We got another rewrite. Then we have our definite integration. We have to know trig values. It's a really good problem. But we're good? Okay. All right. Next one. Average value. This is good because we're still messing up the average value problem. Average value, guys, is just a formula. 1 over b minus a antiderivative a to b f of x dx. Okay. The average value of a function means I want the average height of the function. That means you find the area under the curve, which is the antiderivative, and multiply by 1 over the width. That gives you your height. So again, remember, average value, 1 over b minus a antiderivative a to b f of x dx. That is your average value function. This is the average value. And a lot of times you call that average value f of c, where c is the x value at which that average height occurs. It could occur more than once. For this particular problem, we'd have 1 over b minus a, pi over 4 minus 0, antiderivative, 0 pi over 4, tangent x, dx. Ms. Bonner, how does this relate to the real world? Who cares? It relates to calculus, and you're getting college credit for calculus right now. These are processes we have to know for calculus. Okay? Okay, 1 over pi over 4. That would be 4 over pi, wouldn't it?
Yep.
What's the antiderivative of tangent? You just learned it.
Negative natural log cosine absolute value. You need plus you don't need that. Oh wait.
Okay. Again, we could reorganize this a little bit, put the negative out in front or whatever. I mean, just be careful with what you're doing. Sometimes I'll just leave the 4 over pi out in front, put a parentheses, so I don't confuse myself, because again, I'm trying to work quickly and not have to think so much, just react. Pi over 4, and then it'd be minus negative, right? So then plus. All right, so we have negative 4 over pi, natural log, cosine pi over 4 is root 2 over 2. Do we need absolute value for root 2 over 2? Plus, that would be what? 4 over pi times natural log of cosine 0, the width at 0, 1. Don't need the absolute value signs anymore. And natural log of 1 is my favorite natural log. Goodbye. All right, so then rewrite one last time. That would be our exact answer. No idea what this is approximately equal to. Maybe like that. Check me, see if I'm right.